Hello friends, today I will solve a LeetCode easy problem on arrays. So the problem says, a school is trying to take an annual photo of all the students. The students are asked to stand in a single file line in non-decreasing order by height. So let this ordering be represented by an integer array expected, where expected I is the expected height of ith student in the line. And we are also given an integer array heights representing the current order that the students are currently standing in. So each height of I is the height of ith student in the line. So we need to return the number of indexes where heights of I is not equal to expected of I. So let's consider the first example. So we are given heights array of values 1, 1, 4, 2, 1, 3. So the expected array will be the heights array sorted in non-decreasing order. So if I compare the heights of heights array and expected array, I can see the heights differ at indexes 2, at index 4, and at index 5. So the output will be 3. Similarly, I will consider the second example. So here the heights are given as 5, 1, 2, 3, 4. So the expected array will be 1, 2, 3, 4, 5. The heights are sorted in non-decreasing order in expected array. So I can see all the indexes in heights array and expected array don't match. So the output will be 5. Now I will consider the third example. I can see in the heights array, all the heights are sorted in non-decreasing order. So the expected array will be same as the heights array. So we can say as all the indexes match here, so the output will be 0. So now I will code the problem. So first I am declaring an expected array of height n. So I am creating an expected array from the given heights array using the clone method. Then I need to sort the expected array as all the heights in the expected array are supposed to be in non-decreasing order. So now I'll sort the expected array. Now I'll declare another variable called diff count. Then I will run a for loop from index I equal to 0 till I less than equal to heights.length I plus plus. So if heights of I is not equal to expected I, I'll increment the diff count. And at the end, I'll return the diff count as the result. Now let's run it for the sample test cases. We can see it's working fine. Now I will submit it. So it's working as expected. So here what we are doing, first we are declaring an expected array, or we are creating an expected array from the given heights array using clone method. Then I am sorting this expected array, and at the end I'm comparing the heights at each index of heights and expected array. So this is a linear step. So the sorting is upper bounded by big O of n log n, and other steps are linear. So we can say the time complexity is big O of n log n, and the space complexity is big O of n. Now we can see it's given that the heights of I is less than equal to 100. So all the heights will be upper bounded by 100. So instead of sorting, we can count the frequency of each height, and we can construct the expected array from the frequency count. So now I'll discuss this approach with an example. So now I'll consider the first example, the heights 1, 1, 4, 2, 1, 3. I'm declaring an array called heights frequency to store the frequency of each height in the heights array. So it will be of size 101 because we are given the maximum height can be 100. So the heights will vary from 0 to 100. That's why we are declaring a size of 101. So initially all the frequencies will be initialized to 0. So now I'll go through each height in the heights array and I will increment its frequency. So for the first height, it will be 1. Then I'll go to next height, that is 1. So I'll increment the frequency of 1 to 2. Similarly, I'll go to the next height. I'll increment the height 4's frequency. Then I'll go to next height. I'll increment the frequency of height 2 to 1. Now I'll again go to next height. Then I'll increment the frequency of height 1 to 3. Then I'll increment the frequency of height 3 to 1. Now I will construct the expected array from the heights frequency array, and it will be of size n, that is the size of the heights array. So you can see in the heights frequency, the frequency of 1 is 3. It means the height 1 is present 3 times in the heights array. Similarly, height 2 is present 1 time, similarly height 3 is present 1 time, and height 4 is present 1 time in the heights array. So now I'll traverse the heights frequency array. I can see height 1 is present 3 times, so its frequency is 3. So in the expected array, height 1 will be present 3 times. Then I will go to next height, that is height 2, its frequency is greater than 0 and it's 1. So height 2 will present 1 time in the expected array. Similarly, height 3's frequency is greater than 0, so height 3 will present 1 time. Similarly, height 4's frequency is greater than 0, so height 4 will present 1 time because its frequency is 1 in the expected array. Now I'll traverse both the heights and expected array. I'll declare a variable called diffCount that is initialized to 0, and I can see at index 2, 4 and at index 5 the values at heights array and expected array differ. At index 2 the value at heights 2 is 4 and at expected 2 it's 1. So I'll increment the diffCount to 1. Then at index 4 the values differ, so I'll increment the diffCount to 2. Then at index 5 the values differ, so I'll increment the diffCount to 3. So in one linear traversal I can find the diffCount. So I'll return the diffCount as result. Now let's consider the second example. So I'll construct the heights frequency array from the heights array, which is an integer array of size 101. So all the frequencies initially will be set to 0. Then I'll linearly traverse the heights array, and for each height I'll increment its corresponding frequency. So for 5 I'll increment to 1. Then for 1 I'll increment its frequency to 1. Similarly for next height 2 I'll increment its frequency to 1. Similarly for next height 3 I'll increment its frequency to 1. Then for height 4 I'll increment its frequency to 1. Now I'll construct the expected array from the heights frequency array. So the expected array is of size n, that is the length of the heights array. So I can see in the heights frequency array, all the heights, that is heights 1, 2, 3, 4, 5 occur one time or their frequency is 1. So in the expected array, all the heights will present one time. So now I'll declare the diffCount variable that is initially set to 0. Now I'll linearly traverse both the heights array and expected array. As all the indexes in the heights array and expected array differ, so the diffCount will be 5. So now I will code the problem. So first I'll declare heights frequency array of size 101. Then I'll declare expected array of size n. Then for each height in the heights array, I'll increment its frequency. Then I'll declare another variable called index. Then I'll run a for loop and I'll traverse each index in the frequency array. If at index I the frequency is greater than 0, it means there is an height of size I in the heights array. So I'll store that height in the expected array. So I'll set expected of index plus plus to I, then I'll decrement the frequency at index I. Then I'll declare another variable called diff count. Then I'll linearly traverse both heights and expected array. So for int I equal to 0, I less than I plus plus. If heights of I is not equal to expected of I, I'll increment the diff count. And at the end, I'll return the diff count. Now let's run it for the sample test cases. We can see sample test cases are running fine. Now I'll submit it. So it's working as expected. So you can see what I'm doing here. I'm declaring two arrays, height, frequency, and expected. Then for each height in the heights array, I'm incrementing its frequency. So this is a linear step, big O of n step. Then I'm linearly traversing the frequency array, and if the frequency is greater than 0, I'm storing that height in the expected array. So at the worst case, it will take 101 steps. That is the length of the height frequency array. Then at the end, I'm linearly traversing both the heights array and expected array, and if the height are different at index I, then I'm incrementing the diff count variable. So you can see the length of the heights array is less than equal to 100, and I'm declaring an height frequency array of size 101. So the time complexity will be big O of 100, that is greater than or equal to big O of n. Similarly, the space will be big O of 100, that is greater than or equal to big O of n. So in most of the cases, it will be faster than the sorting based approach we discussed initially.